Hey guys, welcome back to the channel. If it's your first time here, my name is Aiden Potts and we go through math and physics tutorials, as well as how to improve the mindset and learning skills of a student. In today's video, we're going to be going over trigonometric equations and how they differ from trigonometric identities. We'll be going through multiple example problems where we go through and solve each of these trigonometric equations. By the end of this video, you'll understand the difference between proving trig identities and solving trigonometric equations. You'll also understand the strategy on how to solve these trigonometric equations and ensure we get the precise angles, like the exact angles, as well as all possible solutions to the equation. If you guys like this content, I'd really appreciate you liking the video and subscribing to the channel to see more videos just like this. Okay, so before we get into the problems, I want to go over kind of the difference between trigonometric identities and trigonometric equations. We'll also be going over kind of some things to remember to ensure we can actually do these problems that we get. So trigonometric identities are equations, like they have an equal sign, but they're true for all possible values. And since we're dealing with trig, it's going to be all possible angles. So an example would be something simple like sine of x equals sine of x. And I know that's just the left side equals the right side, but that's kind of what we're showing in the trigonometric identity. It doesn't matter what value of x we get, the left side will always equal the right side. Now, a trigonometric equation, this is only true for some possible values. This is going to have certain values of x where this is actually the case, and other values where it's not the case, and it doesn't work. So an example of this would be sine of x equals cos of x. For this example, what we could do is we could divide, and we could bring it to this side. We could do sine of x divided by cos of x is equal to 1. And we know that sine of x divided by cos of x, that's really just tan of x equals to 1. So here the solution would be inverse tan of 1. And that's going to give us our angle value of x, where tan of x is equal to 1. So that's what we're kind of doing when we're doing trigonometric equations. We're solving for certain x values where that would be the case. For identities, it's always the case. It's for all possible angles. Now, some of the words that you should be looking for when you're trying to decipher whether or not it's an equation or an identity. For identities, they're going to say things like prove, verify, or show. Whereas for equations, they'll say solve or find solutions. So now we're going to go into things to remember. And so one thing that we need to remember for sure is special triangles. This is when a question asks you find the exact value of x. So they don't want to do like sine inverse because that's going to give you a decimal, or cos inverse, or tan inverse. What they want you to use is use our special triangles. So we have our pi over 4, pi over 4, pi over 2 triangle. And that's a special triangle. So we have to remember whenever we see values of 1 over root 2 or root 2 over 1, that can be solved using our angles of our special triangle. The other triangle is our 30, 60, 90. In this case, it's pi over 3, pi over 6, pi over 2 if we're doing it in radians. That's another special triangle we should know. Next, we have the CAS rule, or like the all students take cracker rule. So we need to understand where certain values are positive. So in the second quadrant, sine is positive. In the third quadrant, tan is positive. Fourth quadrant, cos is positive. And in the first quadrant, all are positive. We also need to remember quadratics and some trigonometric identities. So even though we're not trying to prove an identity, we're still going to use some of the identities where we already know of, like the double angle identity, maybe the compound angle identity, and that will allow us to solve the equation more easily. And for quadratics here, what we really just need to note is that whenever we see something of this form, we know that we can factor it, and there's going to be two possible solutions to get for our x value. Okay, so before we move on to this example problem number 1 here, what I want to make clear is for identities, we don't typically go over the equation sign. We don't go left and right over the equal sign. We don't bring things across or bring things under. What we want to do is prove that the left side equals the right side. But for equations, we're trying to solve for values of x where this is the case. So we actually can and we should bring things over to one side and kind of cancel things out in that respect. Okay, so for this question, we have 2 cos squared x minus sine x minus 1 is equal to 0. So we're trying to figure out what values of x correspond to make this equation valid. So here, what I'm going to do is I'm going to use our first identity. We know that cos squared x plus sine squared x is equal to 1. That's our Pythagorean theorem identity. It's the one that comes up quite often. So what I'm going to do is I'm going to solve for cos squared. So cos squared x is equal to 1 minus sine squared x. Now I can plug in this 1 minus sine squared x wherever I see cos squared x. So I'm going to go plug that into that value right there. So then we're going to get 2, and it'll be 1 minus sine squared x minus sine x minus 1 is equal to 0. if I expand this bracket out, I'm going to get 2 minus 2 sine squared x minus sine x minus 1 is equal to 0. And now collecting like terms, I'll get negative 2 sine squared x minus sine x, and then this 2 and this negative 1, that's just going to be plus 1 equal to 0. Now to get rid of some of these negatives, what I'm going to do is I'm going to multiply both sides of the equation by negative 1. So here this side will be 2 sine squared x plus sine x minus 1, and this side obviously 0 times negative 1 is just still 0. So now what we're going to have to use is one of the quadratic properties. So whenever you see this, like a sine squared x and sine x and a constant, what we can do is I can say a is equal to sine of x. So wherever I see a sine of x, I'm just going to replace with the value a. So this is 2a squared, because it's sine x squared, plus a minus 1 equals 0. And now this is a form that we're much more familiar with and we can kind of work with to solve for this equation. So we know it's quadratic, we know there's going to be two solutions. So let's just factor this quadratic. So we're going to do 2a squared, and then it's going to be plus 2a minus minus 1a minus 1, and that's going to equal 0. So now I can factor by grouping, and I can do 2a plus 1, so I'm grouping these two together, and then minus 1, so I'm going to factor out a negative 1, so it's going to be a plus 1 is equal to 0. At this point, we can now see that this a plus 1 term is common, so what we can do is we can factor that out and say a plus 1 multiplied by 2a minus 1 is equal to 0. And so now this is a similar kind of equation where we can solve for our values. We know that a plus 1 will equal 0, and 2a minus 1 will equal 0. So what we can do now is we can solve a is equal to negative 1, and then we also have 2a is equal to, or on this side it'll actually be a is equal to 1/2. Now we resubstitute what our a value really is, which is sine of x. So sine of x is equal to negative 1, and sine of x is equal to positive 1/2. So what we're going to do is we're going to rotate an angle. So this, from the origin, like on this unit circle, it's going to rotate all the way around, and this is where sine is negative 1. Right? At this angle right here, this is 3 pi over 2, and that is where sine of x, sine of 3 pi over 2 will equal negative 1. So we know that one of our x values is 3 pi over 2. So now we need to figure out an angle where sine of that angle is equal to 1 over 2. So if we look at our special triangles, and we kind of have to use the unit circle, our cast rules, as well as special triangles to solve these equations. So what we have here is sine is opposite over hypotenuse. So if I take sine of the opposite of pi over 6, that'll give me 1, and then the hypotenuse is 2. So we actually know that x is equal to pi over 6, because from our special triangles, that's going to give us a value of 1 over 2. Now unfortunately we can't just stop there, so that is a solution, but there is one more. So here we know that from cast, we know that pi over 6 is going to exist in this quadrant, and that will give us a value of 1/2 for sine. But it also is positive. Sine is also positive over in this quadrant. So what this is if we look at this reference angle, this is the angle pi over 6, but we take angles from this distance here, from this x-axis. So that angle value is actually not just pi over 6, but it's 5 pi over 6. So with this, we have x is equal to pi over 6, 5 pi over 6, and x is also equal to 3 pi over 2. If that was confusing, don't worry, a lot of these questions are very similar, and a lot of the things we've done in the first question are going to carry over, so I don't need to go through them as intensely. But here, we start off and we see sine of a double angle, so a double angle formula. I know that sine of 2x is 2 sine x cos x, and then that would be right here, so it's still multiplied by cos x, and I'm going to bring this sine x over here. So this is going to be minus sine x, and that's going to equal 0. Now what I can do is there is a common term for sine of x here and here. So I'm going to factor that out. I'm going to say sine of x, factor, or bring it out of the brackets, and this will be 2 cos squared x minus 1, and that is equal to 0. Now once we've gotten to this form, we can actually solve this equation. So one of the values is going to be sine of x is equal to 0, and the other one is 2 cos squared of x minus 1 is equal to 0. So this one's pretty much solved, and we can kind of go through the angle, but let's simplify this side a little bit more. So this is going to be cos squared x is equal to 1 over 2. And I just moved the 1 over and divided by 2. Now if I take the square root of that, I'm going to get cos of x is equal to, well, square root of 1 is just going to be 1, but square root of 2. And this is a big important point. Whenever we take the square root of something, we have to say plus or minus. So this is plus or minus. So cos of x, well, the square root of 1 is just 1. So we can just write 1 on top, and then this is plus or minus square root of 2. Okay, so at this point, we can solve this side. We know that x is equal to 0, or sine of x is equal to 0 at 0 and 2 pi, right? It's along this axis here. There is no horizontal or vertical direction for on the x-axis. And if we rotate 2 pi, that's going to be back to where we started. So those are two values right there of the x values that satisfy this equation. The other values, we have to look at another special triangle. So here, if we look at this triangle, what we have is our pi over 4, pi over 4, pi over 2 triangle. So x is going to be, so cos of x is 1 over root 2. Well, cos of pi over 4, that's going to be 1, because that's the adjacent side, divided by root 2, and that's the hypotenuse. So we're going to get pi over 4. And that is the first angle that satisfies this equation. The thing here is we have plus or minus, so it can be negative 1 over root 2 or positive 1 over root 2. So if we look at our cast rule here, what's going to happen is we're going to have a value here, and I'll do this in red. We're going to have a value here. This is pi over 4. And that's positive, right? Because we're in the all quadrant. Cos is definitely positive in this quadrant. But it's also when cos is negative. So cos is negative in this quadrant and in this third quadrant. So we're going to have, this is pi over 4. This is also pi over 4. And finally, we only had one of the solutions where cos was positive. There's also another solution here. So we get kind of this x pattern here to show us all the angles. So this is pi over 4 as well. So then we have actually 4 solutions to that one part of the problem. So our first solution was pi over 4, but this reference angle can be taken in all 4 quadrants. So we're actually going to look for this angle here, which is 3 pi over 4. We're going to go to this angle here, I'll do it in blue, this angle here, which is, what is that going to be? That is 5 pi over 4, because it's 1, so if this horizontal distance is pi, then it's 1, or it's pi over 4 greater than pi, so it's 5 pi over 4. And finally, we're going to go for this largest angle, I'll do it in purple, and that is going to be 2 pi minus pi over 4. So that would be 7 pi over 4. And that gives us all of our answers. So we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, along with our x is equal to 0 and x is equal to 2 pi. So those are all the possible answers for this question. Okay, so now we're on to example problem number 3. I'm going to factor this, or expand this bracket out. So this is going to be negative 2 plus 8 sine squared x plus 1 is equal to 2 sine of x. Now I'm going to collect like terms. I'm going to have put 8 sine x squared first. This is going to be, I'm going to bring this over. So this will be minus 2 sine of x. And then negative 2 plus 1, it's going to be negative 1. That's all equal to 0. Here, again, I'm going to have a quadratic. So I'm going to say sine of x, I'll do it in red. Sine of x is equal to a. So wherever I see sine of x, I'm just going to put a. So this is 8a squared minus 2a minus 1 is equal to 0. Now I'm going to look at this equation and go, okay, well 8 times 1, so that's going to be 8. What sums of the factors of 8 get me to negative 2? So we have 1 and 8, we have 2 and 4. So if I had to do negative 4 and positive 2, that will get me my negative 2. So this will be 8a squared, and this is going to be minus 4a plus 2a minus 1 is equal to 0. And now I have 4 terms, so I can factor by grouping. I'm going to do 4a, I'm going to group these two together, and these two. So I'm going to have 8a squared, so 4a, if you take that out, that's going to be 2a minus 1, and then plus, well, if I factor out a 1 here, this will just be 2a minus 1 as well, and that equals to 0. Now, I have this common term 2a minus 1. So what I'm going to do is I'm going to factor that out. So we have 2a minus 1 times 4a plus 1, and that is equal to 0. And here we're going to have two solutions. So I'm going to have 2 sine of x, because remember a is equal to sine of x, equals 1. And then I'm going to have 4 sine of x equals to negative 1. So here we have sine of x is equal to 1/2. And this is the same solution we got before, and it's positive, so I can already know that x is going to be pi over 6 and 5 pi over 6. So I already know those just from doing the previous problem where we solved for what values of x give us 1/2 when we take sine of it. For this one, I'm going to get sine of x is equal to negative 1 over 4. So negative 1 over 4. So this is where our special triangles don't really help us, because our special triangles don't have a 4 in the numbers, in the side lengths, right? So there really isn't an angle that's going to be an exact value of negative 1 over 4. But what we can do is we can do sine inverse. So I can take sine inverse in my calculator of negative 1 over 4. And what I'm going to get is, if I do sine inverse of negative 1 divided by 4, I'm going to get, and make sure you're in radians because we're still doing things in radians. So this is negative 0.25, and I'll round to the hundredth, rads. So that's negative 0.25 radians. The thing is, though, we have to be careful. So this is one of the solutions. The calculator gave us one solution, but it didn't give us both. So we're looking for negative 1 over 4. Well, we know that sine is negative in this quadrant, and it's negative in this quadrant. So basically, we're going to have two solutions here. We're going to have this first solution, which is from here to here, and then this second solution, which is from here to here. Make that a bit more clear. So we got negative 0.253. So negative 0.253, that's like the calculator telling us we're going in this direction. This is 0.253 radians, and that's going to give us a value of negative 1 over 4. But typically we don't do it that way, so I'm going to do 2 pi, and then I'm going to say minus 0.253, and that's going to give me this blue angle. So I'm going to get one of the angles to be, I'll do x is equal to 6.030 rads. So that's one of the solutions. And then again, I have to kind of remember that this 0.253, that's this terminal angle, so that's right here. So I have to add pi to that because here to here is a value of pi. So I'm going to do pi plus 0.253. And then I'm going to get a value of x is equal to 3.395 rads. And these would be the two answers that satisfy sine of x is equal to negative 1 over 4. Okay, so now we're on our last problem. And again, we see that there's this quadratic looking thing. So again, I'm just going to substitute a variable in. I'm going to say sine x is equal to a. So 8a squared plus 2a minus 3 equals 0. And if you have no problem looking at sine squared x and sine x, go ahead and you don't need to use a substitution. I just find it's easier to kind of see this and be like, okay, I know this is quadratic now, and I know how to solve it. So what we're going to do is negative 24, that's 8 times negative 3. The factors of it are going to be 124, 2 and 12, 3 and 8. Let's see, what do we have? 4 and 6. And we need some of these to sum to 2a. So what's going to be is going to be 8a squared. It's going to be 6 and 4. Because if I do positive 6 and negative 4, that's going to be positive 2a. And then 6 times negative 4 is going to be negative 24, which is what we're trying to get. So this is going to be plus 4a, or sorry, it'll be, I can do plus 6a minus 4a minus 3 is equal to 0. And now I'm going to group these two together. So I'm going to say 4a, this is 2a minus 1, and then these two together. So we'll have 6a, so this will be plus, if I factor out a 3, it's going to be 2a minus 1. And this is all equal to 0. So now I have a 2a minus 1 that's common. I can do 2a minus 1 multiplied by 4a plus 3, that equals to 0. So again, we're going to get 2 sine of x is equal to 1. So sine of x is equal to 1 over 2. And then this side, we're going to get 4 sine of x is equal to negative 3. So sine of x is going to be negative 3 over 4. We know previously that when sine of x is equal to positive 1/2, we get the values of pi over 6 and 5 pi over 6. So those are two of our solutions. Now here, again, this has this over 4, so we actually don't know what this is. So we're going to have to do x is equal to sine inverse of negative 3 over 4, and then we're just going to have to account for our cast rule. So if I do sine of negative 3 divided by 4, I get x to be equal to negative 0.848 rads. So now we have an angle that's a little bit bigger, but it's still in the same process. So we're going to do this here is negative 0.848 rads, and that will give us a value of negative 3 over 4 when we take the sine of this value. So again, we have to actually get the value that accounts for this one. So it's going to be 2 pi minus that. And sine of x is also negative in this quadrant here. So we're going to find this value here, where this reference angle is negative 0.848. So for these answers, I'm going to say x is equal to, well, so it's going to be 2 pi minus 0.848. That's going to be 5.435 rads. And x is also equal to, well, it's going to be 0.848 plus pi, and that is going to equal 3.98. I guess it's going to be, if I round properly, this is going to be 4.00 rads. And that would be our final answer there. Alright, so I hope you guys got some value out of this video. If you did, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. I make a ton of content related to math and physics tutorials, as well as how to improve the mindset and learning skills of a student. If you guys have any ideas of what material you want me to cover next, let me know down in the comments below. Thanks again, and I'll see you guys in the next video.